correctly. Right. Cool. I'm live. So I was gonna work on. Actually, I didn't have plans for what I was gonna work on today. So one of the things I wanted to do was last stream we were looking into trying to visualize the BVH. However, that was providing me with way more issues than I should have, than should give it me. Because camera. All right. Right, there we go. So it was giving me way more issues than it should have. So right, yeah. So I decided to scrap that for now and focus on something else. So one of the things I wanted to do is fix the transform actually. So if I fix the transform, I can actually make a free camera that allows me to fly through the scene. So that will give me some more debug abilities. Right. So the issue that we currently have, right, is if we rotate the model, so I think we, at this line here, right? So if I enable this, so we simply rotate it a bunch of time with the delta sign, right? Come on, yeah, there we go. See, it messes up the texture, the sampling, because the intersection point is wrong, right? So that is quite simple to fix. So let's keep this enabled. No, sorry, let's keep this disabled for now. And go back to the Raytracer. So this is so if this is a thing and current model distance is less than distance, right? Okay, cool. So this is fine for the most part. However, the intersect here is based on local space, I think. Yeah. So do I take the... Yeah, I do transform the ray here. So that means that the T is now relative to this transform position. Right. So that would mean if I... yeah. Origin 1.f. Oh, right, yeah, so I'm doing the... Yeah, sure. No, that should be correct. Then... oh. Yeah, so that will give me the T value. And then once we get the T value, we need to calculate the intersect points and then transform that back to world space. Yeah. Okay. Sure. However, is that the correct approach? Because I'm trying to see what has the least amount of calculations needed. Right. Yeah, no, this should be correct, right? So then we have the distance. Then we go to the Raytracer. Right, so this inverse doesn't actually do anything, what I had hoped it would. So if I remove this, right, it doesn't magically become correct either. I'm guessing. Or sorry, if I now, what do you call it, in main, re-enable the transform. So this should still be broken. Come on, run, thank you. Yeah, so it's still broken, cool. Just wanted to validate my my claim, my expectations. Right. So, right, we want to get an intersection point. So glm vec3 intersection, yeah, intersection point, and this can be sure that can be that. So the distance here is a bit more nuanced. So so if current model triangle, right, that would mean that we intersected something. Then we want another if statement. So if, right, sure, this will do something else. So if true, right. So then we want the intersection point. What would be glm vec4? Let's keep this vec4 here for the meanwhile. Local intersect. Local intersect, and this is equal to ray.origin. Do I actually want to pass in? No, right, because this, I just realized, right? So we transformed the ray in the BVH. However, we don't know the resulting thing. So in here, we actually don't want to do this. So we want to move this out, then pass in ray, right? And then in the Raytracer, we actually want to transform the ray. So this is the transformed ray, and this would be m.activeScene .models, and this would be .y. And then I do need the get transform, and then that would be the same here. Wait, can I not do this, or is this the dot? Ah, right, sorry. And then this would be the exact same. And then the dot, right. Sure. So now we have the transform ray, and instead of the current ray, we pass in the transformed ray. So if that intersects, we need to know the distance. So where did I get the current model distance? Cool. So then current model distance is actually something else. So intersect point. Sorry, did I have the? No, I didn't have the glm vec3 here, 4 yet here yet. So glm vec4, that would be local intersect. Local intersect, right? And local intersect equals glm is it transformed ray dot origin plus transformed ray dot direction times current model distance, right? And this would be glm vec4. Then we have the local intersect. I can just assign this actually directly. Right. So local intersect is equal to this. Then we want to get the distance from the so glm vec3 actual distance. Right, actually I don't need this to be a vec4, I just need this to be a vec3. My bad. I thought we would need... No, sorry, we do need this to be a vec4. My bad. So then local... yeah. And then it would be get transform, and this would be glm inverse of the transform, and then multiply that. So this would give us the point in roll space again, and then we would do if glm distance 2 from local intersect and ray.origin is less than distance, then this is all true. Right. And then this would be glm square root, because we had the square distance. However, wait, okay. So I want another float here. Float. No. Yeah, we can. This would actually be inefficient just to have multiple variables. We can just. It would have been nice to get rid of this, but we still need to do the square root in the very. No, we don't actually need to. Right. We can still do distance 2, and that would be fine. And then in the very end, we would say if hit, right, distance equals glm square root distance. Right. This way we do actually remove a lot of square roots. So do we now have the intersection fixed? No. That would have been nice, but I suppose not. Right, I'd really hope that would have fixed it. So why does that not work? So the transform, the local intersect now should be fine. Yeah. Sure. Okay. So in the because I remember having, I know the issue, right? But let me check my old Raytracer. Because this should be a relatively straightforward fix. Right, so in the Raytracer, my old one, I'm just checking. There. So we get the intersection point. And if, yeah, sure. So get closest objects, right, sure. Do I transform the ray in here? Studio's being so slow. Right. So intersection test, right, sure. So let's take this intersection test. No, I want the, let's just take this square intersection test, sure. So the local is the, we need to, right, we're doing the calculation wrong. Sure. It would be multiplying with the inverse in here actually, right? We don't need to cost inverse here at all, because that's actually rather wasteful. So this would be get inverse, and this would be get inverse, right? And what does this do? Sorry, I do need to remove the breakpoint. Right. No, that doesn't quite fix it either. So I'm just curious, right? So if I replace this line with if distance, so if, what was it? The current model distance, right? So if we simply pass in that, do we get the shading? Not the shading, do we get the texture working? No, okay. Right, so looking back at the old Racer, right. So the transform rate is the inverse, yeah, sure. So that would be, direction, so this is 0 and this is 1. Okay, that's good, the W component. Same with direction, sure. Then Yeah, sure. And then to get it back, we get the local transform. Yeah. Yeah, and that gives us the accurate intersection point. That should be fine. All right. So we inverse, okay. Current model triangle. So intersect, and that is the transformed ray that we're passing in. Current model distance, right, sure. And the local intersect is this again, so that would be transformed ray origin plus transformed ray direction times distance. Yeah. That's the local intersect. Where's my world? Is this in the bvh.cpp? I think it is. Oh, wait, sorry, this is the wrong project. I'm trying to look at my old project, sorry. So if ray origin dot minus temp hit dot length 2 is less than distance 2, okay. Yeah, so this should be fine. So I'm kind of curious why this isn't working. Unless the transform is wrong. However, I would find that odd, as we're not setting a lot of things in the transform, right? So in the we can take a look at it. The recalculate and see what it does. Right, recalculate. So the translation is just 1 1 1 1. Yeah, so that's identity. Rotation should be identity as well. Yeah, sure. And scale should be identity as well. Yeah, okay, cool. And inverse is just the inverse, right? So next time we set this right. The translation is still the same. However, rotation should now have a value. No. Wait, so what's calling this? Yeah, we're adding a rotation. Yeah. So how is m.rotation? Okay, no. Okay, just to go all to update. Oh. Wait a second. This doesn't look like radians at all. Okay, right. But that could simply be due to the delta time being what it is, right? So right, so it is rotation.x. Yeah, so that would be fine. That's like 2 pi. Sure, that's yeah, that's like about 1 rotation, almost something. That doesn't really matter that much. Right, so rotation should now be some weird garbage. Oh well, not garbage, but you know, the should be translated. Yeah, and rotation should be the weird one. This is all still identity because this is all 1 1 1, and this is also 0 0 0. Okay, that's perfectly fine. So that means that I'm actually doing something wrong with the transforms. Okay. So going back to the Raytracer, yeah, so we transform it here with the inverse. because we're trying to get it into model space, right? Okay. So go here. Right, what is the transformed ray? The Y didn't change at all. The X should have changed massively. Yeah, because we transformed the model by quite a lot. Because it's rotated, right? So that's fine. Right, so what is the local intersect now? Right, that's this value. Okay, and the triangle, right? Right, so the closed triangle is this. And sorry, look, local intersect is 5.2. Okay, right. So let me see if this is in the thing. So vertex, no. Okay, it's completely outside of the triangle, right? Because it's -2, -2, -1. So a thing of like, what was it, 5 point something? Doesn't make sense at all. So that means we're either getting the wrong triangle, what I doubt is the case, because otherwise we wouldn't have got them all in the first place, or the this is going wrong. The transform. Oh, with this, no, because I would be getting the points. Right, what if I do instead of, no, okay, right. Because the intersection point is based off the transformed ray. Because that is what we've been calculating. The T is based off the ray that's being passed in. Yeah, because it's the hit is the, right. Yeah, because it's based off the local. Could it be that I don't normalize the direction of the new array? I'm just curious about that. I could try that. So in here, in the transformed ray, this is the origin. No, that's fine. And this should be normalized, right? Come on. So glm normalize this. Right. Does by any chance that make any difference whatsoever? No, that would have been great, but I suppose not. Right, so the local intersects is x is 2. Okay. No, what if we're getting the wrong PVH? No, that's still fine. Because we're getting the, no, that's still fine. We're still getting the closest PVH based off the transform, because we're going through all the nodes with the transformed ray. However, could I not just do the following? I get the intersection point, just like normal, and then I multiply the intersection point with the matrix of the object, and use that distance. Alright. I think that could work. Because then we're treating everything as it's at 0, 0, and at the very end we're simply moving it. I think that could work potentially. So we're only taking care of the camera transform. Right, so if we simply choose to ignore this, right? So we pass in the intersect, and we just pass in ray. Oh. Alright, sorry. Excuse me. And this would be the just ray.origin and ray.direction and current model distance, right? And then that would be cast like this. Oh, no, wait. No, I think what we were doing before was actually correct. No, sorry, should be get inverse. Right, I think the reason it's actually not working here is because we need to multiply with the inverse. Right, so let's make us a glm mat4 here, right? Just for testing. That would be test inverse. Right. And test inverse here is the test inverse is equal to this. Right. And then we pass in here, apply shading, yeah. Right, get texture would be hit point, test inverse times hit point, and this would be a glm vec4 hit point, comma 1.f, right? Because I just realized it's in world space, but we need to be in local space. Yeah. Get away brickwind, right? That's a shame. And if I do get transform, would that make a difference? No, okay. So I've noticed one thing today, and that is math skills are horrible during the vacation times. For some reason, like all day and yesterday as well, I've been stuck on math that I've like done 20 times before, and I can't seem to figure them out for my life, right? So this is actual garbage. Okay. Sure. So let's just remove this. And then just pass in ray, like before. Okay. And then if distance, distance, no, what was it? The current model distance. If current model distance is less than distance, right? And then closest model, no, that we don't need this one anymore. And this would need to be, yeah, removed from there as well. Okay. Test inverse is still there, okay. And the intersection point can go as well. Okay. So this should work and give us the, should still give us the same thing. Right, I think that's working. However, I think the light is in a bit shoddy position. So I can move the light a bit to see if it's working correctly. Because I think during some testing I have moved the light, so that could be why it's very dark. No, okay, that seems to be actually very, very broken. That's interesting. Okay. Oh, right, we did do the square root here. We don't actually want that anymore. Yeah, there we go. Now we're back to the texture. Cool. That is what we wanted to see. Okay. So now it's time to figure out how I can do basic games programming math without breaking my brain. Right, so right. So I'm kind of curious if there is a nice way in online resources that can give me information about this, right? So there is right. So there's Intersect here on Scratch a Pixel, right? So they multiply it in here, right? And that T, yeah, but it's an object space, right? So yeah, it is as I said, right? Hey, sup, Tech Geek. Well, it's going with mixed opinions. Oh, sorry, not mixed opinions, mixed results. For some reason, because it's vacation time, my brain decided that mathematics are just not needed anymore, and I'm getting kind of stuck on math. So I'm trying to fix my transforms, so I can actually move objects in space around without the textures dying completely, right? So we can see here that give it a second to compile, the model is now loading correctly, and it renders as well. However, when I actually transform it, the texture becomes completely broken. And I think it's simply because it's calculating the bar center coordinates and texture coordinates wrong, right? Because they're based on the intersection point, and if the intersection point is outside of the triangle, it will do weird stuff and give me insane values, right? But for the rendering part, it's fine, because whatever I do, even if the texture coordinate is wrong, it will still give me the correct result, at least with one model, right? So I've been trying to figure out how to fix that, which shouldn't be that hard of a problem because I've made a Raytracer before, but for some reason my brain can't comprehend what I'm doing. But there is actually some stuff I did get working with this, and I hope as well, if I fix the transforms, I can visualize the BVH as well, right? Because we can see that this is running in, I would say, real time. It's close enough, 20 FPS. And this is a model with, I think, like, I forgot how many triangles we actually have. Let me double check that. So breakpoint. Right, so active scene, models. Okay, I would have to do that in debug. I think we're running like 30k triangles in 20 FPS. And the impact with more models isn't really any higher. Pointer, models, 0. Right, so 26,880 triangles. No, sorry, vertexes. Whatever. Anyway, quite a lot, right? And by the way, Tech Geek, thank you for the follow, man. Means a lot. Right. So, sorry, coming back to the problem. The transforms. How I'm actually gonna try to fix them. So, yeah, right. Give me 3 seconds for my brain to catch up. Right, okay, cool. So, what we should be able to do, if we have a model transform, we need to put it into object space. What I think is multiplying with the inverse. Right, so we have the multiply factor world to object. So I think that's multiplying by the inverse. World to object matrix, right? So that would be Right, so world base. Yeah, so that's the inverse of the model matrix times the world position. Okay. So the world position. Yeah, okay, cool. So we need to transform the array here before we do the intersection, right? So we have a glm vec3 transformed ray direction, and that's equal to let's actually get a model reference here. So I think this is a, let's do just an auto ref. Const auto ref, const auto ref, and this is equal to this model, right? Model ref, and this is model ref dot transform dot get inverse, and that times a glm vec4 of the ray dot direction dot 0 to left, right? And the w component is 0 because it's a direction. So for the transformed ray origin, it's going to be very similar. However, this would be the ray origin, and this would be 1.f. So then we want to construct a new ray. So ray transformed ray, and that's equal to TRO and TRD. And I put an O here instead of a 0 instead of O, right? So this would be the transformed ray. So if we now put this transformed ray in, the distance here would be, yeah, ray tracing is really, really awesome. Wait, let me actually show you something else, right? So this is the old Raytracer that I've been working on. I'm trying to get it on screen, right? So if I run this in release, we can see this one is chugging very hard. Oh, my stream is also dying. Oh, okay. Bad idea. But let me turn down the multi-core usage here a bit. I think I put this in the, I think this is in, no, the Raytracer. So I think there is the S to D. Yeah, so this would be, oh. Right. So this project, I think I've put about 15, 20 hours in it maybe. And this this Raytracer here that we can see would be 8 weeks of 40 hours. So that this would be like 200, no, sorry, 3, I can't do basic maths anymore. So 8 times 40, yeah, so this would be about 320 hours, this Raytracer. So it has a bunch of similar features. However, we can see that this is chugging much harder. So this is running at around 4 FPS, right? And the old Raytracer, the new one I'm building, is running at a much higher frame rate. So we can even take the same model to compare it a little bit. I mean, to be fair, the old Raytracer is doing a bit more work, but this one is actually performing better. But with this one, I have decided to skip a bunch of primitives, so I don't have spheres or planes, because this way I can only deal with triangles, so it'll make things quite a bit easier. However, it also means that I have to deal with optimization much earlier, because for even simple shapes I need quite a lot of triangles. However, with a BVH, this gets sped up massively. So right, I wanted to show the race car. So this would be Ferrari.obj. Right. And something cool here as well, right, that you can see, is that we can see in the console, right, we can see some messages of the BVH being built, right? So it's building BVH, it's showing some debug info here, and it's running. This might actually take a while to build because it's quite a big model. And this is in debug, right? So it's much faster in release. However, there's something cool I implemented here. Because this makes my life very hard to debug, right? Every time I want to debug a model, I have to go sit through this. It would be not great at all. Right, there we go, the car. So this is running at the same frame rate in debug, right? This model. And in debug, in the other one, it's just actually pressing, right? But now, next time we run it, so I run it again, we can see that it loads in instantly, or well, close enough. Bam, there we go. So what I did is I created my own binary format. So let me get the file structure. GitHub. Right. So let me share my screen again. My main display. Right. So we have this format, right? And once it loads in a model for the first time, it will construct the BVH and then construct it in this binary format. And this is, well, a bunch of information that is not human readable at all. However, this is readable by code very, very easily, actually. So if we go into BVH, we have two different things. We have a header and we have a body. So the header is simply a program name. This is just equal to BVH and ASCII. Then we have a version, and then we have some information that we need to read the binary file. And then we have the body, what is just triangles and nodes. Then we read the file, which basically see if it exists, if the file is recent. So if there's a newer version of the header, we want to discard the file, right? And then we simply read the binary data and do a mem copy over the triangles and BVH nodes. So that means we don't have to do the expensive calculations again to rebuild the BVH. What I think is really, really awesome. So that will speed up the work by quite a lot. However, there's no point in having transforms if the shading is all messed up, right? Sorry, I didn't want to run this in debug. My bad. So if I run in release, right, we can see that this one runs much quicker. Right, there we go. However, I think the shading is wrong again, right, because of the intersection points. But this is running in, oh, let me put back to this, right? So depending on how close it is, it runs, yeah, it runs it, if it's very close, it runs kind of horrible. If it's farther away, it will render at about like 20 FPS, right? 20 to 30. But it's very close, that means every pixel has to do an intersection, pretty much. However, yeah. Right. Sorry, I'm rambling on a bit. I kind of lost what I, right. So I wanted to fix the intersection, sorry. So if I put this back to the potato, it should run still fine. Yeah, however, we still have the wrong intersection. Although we can see it blinking very briefly to the correct thing when the intersection is actually completed. Or when the rotation is done, so it's back to an identity matrix, basically, right? So we got the intersection point now in transform space. Then in this we need to transform it back to world space. Yeah, because the intersection is also in world space. Okay. So then we want to... Okay. So GLM distance to the intersection point and the ray dot origin. Right, no, okay. So the GLM world intersect, so GLM vec3 world intersect is equal to model ref dot transform dot get transform times GLM vec4 TRD times current model distance plus TRO comma 1.f because it's a position. Right. Then we do this, cool. And then we have the world intersection. And then we need to actually calculate the distance. So GLM distance is world intersect point and ray dot origin. And it is current model distance. So if that is less than distance, we set all these values, right? So do I now actually magically have my model working as it should? No. Okay. So the next thing that could be happening is the calculations are wrong. However, before I do that, I want to try one more thing. So get transform, and get inverse. Just to make sure I haven't done this the wrong way around. Okay, now it's rotating the other way, I think? Yeah, I think it is. Right, what makes sense because we're doing not the inverse. Okay. Right. So I'm kind of curious why this isn't giving me the correct position. Right. So if hit, let's put this to debug and put this here. So does our intersection point now reside within the triangle? So the world intersect, right, is 1.9. Yeah, sure, that works. Okay, I think that is correct. And the distance should be fine as well, because the world intersects, and right, and this is the what is this, right? This is 15. Yeah, this should be. Oh no! Wait. This is. No, this is still okay. Because we're deciding the distance between the 2 points, so that times that will still be the same point, right? Sure. And then if hit, we still do the distance times ray direction times ray origin for the actual world intersection point. So how come that even when we rotate, this isn't within the thing anymore, right? So let's rotate it a little bit, blah, 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 blah. And breakpoint, right? So world intersect is 1.33, and closest triangle would be, right. So that is actually outside of it. So there might be something worse wrong, what I really don't hope is the case. Okay, so something curious. Let's say I don't rotate, but I translate. So in main, I don't want to translate, I want to translate. And this can be glm vec3 is 1.f 0.f 0.f times sine f of, didn't I have like a angle thingy? No, okay, oh no I don't. So times delta time times 0.01, and this would be yeah, sure. So I think transforms work fine. No, okay. That's interesting. So it's not just rotation that's messed it up. It is it's a lot more things that mess it up. It's the entire package basically. So even transforms mess it up. What is a shame. So if I do this right, so we can see it becoming worse and worse. Okay, so in the, I think material, I have the barycentric coordinate calculation. And material, right. So in here I have the, did I have it in here? Oh no, sorry, this is not the material, this is material. So I have the barycentric coordinates. So what are, this is running in release, that's a shame. Raytracer, sorry, main, put this back so we can actually do it correctly, and then in material, right, and have this run for a few frames. Yeah, so still running a release. My bad, I meant to put this in debug. So v, yeah, so what is this equal to? Yes, it's a negative number. Right. So we can see W is outside of the one region as well, and same for the U is just 0 as well, I suppose. Yeah, because V is 0 and W is a big number, right? So we're completely getting the wrong values, and that is simply because the intersection point is completely garbage, because this one doesn't make sense. Okay. However, what I'm curious about, right? When we do the intersect here, this will transform it with the ray passed in. So the BVH is calculated, everything is calculated now from object space, what is fine. So that will give us the accurate distance in object space. So it will give us the closest triangle in object space. but it's cool. That's exactly what we want. Then that will give us a triangle and the distance, t. Then we see, hey, do we have a intersection? Did we find anything? If so, we want to get it back to world, but it's multiplied by the transform, and then the transformed ray direction. What if it's ray? What if it's the original ray that we have to transform it with? I don't think right, but it could be worth a shot. Because that wouldn't make sense at all. No, that doesn't help at all. Let me just rerun it once, just to be sure. Yeah, that doesn't help at all. Raytracer. Right, so that's the inverse times that, yeah. So this should give me the correct point. It's odd. You know what I just realized could potentially be happening is we're multiplying in the wrong order. However, that should still be fine for... I mean, would it make a difference if I did this? Because I know the multiplication order does matter. No, that doesn't really seem to be helping. However, I could swap them out for both places here. Interesting. Oh, it's probably complaining because we still have this. Yeah, sure. And then we move this to the front as well. I mean, it's not wrong, it's just not multiplying by anything at all. Right, so that is just... ray direction is 0.85. Yeah, it's not actually multiplying, right? Because it's assigning and it's multiplying. Yeah, because it's wrapped from the other way around. Yeah, so that doesn't make... it's really this order. Okay. And then multiply. And then this should be behind here as well. Sure. But that still messes it up. So it would give me the correct triangle, but it seems the local intersect is simply wrong. What is odd to me? So I could do a simple glm-vec3 test. Right, and this right, these two values should be identical, right? These world intersect and test. Right, sorry, I put the breakpoint one too low. So test is minus 3.5. No, okay. That is interesting. Because these should actually be equal. Okay. Right, did I mess up the distance then simply? Yeah. Okay. Yeah. So how is that not correct, right? So Raytracer, sorry, that's weird, right? This is interesting. So then in the BVH, right? So GLAM length, and this would be ray origin minus world intersect. Okay. What does this do? No, so this is still different, right? So this is now 6.0. Oh, hey, now we're actually getting the correct values. I think minus 2.9. Yeah, sure. Okay, that's cool. That's awesome. Okay. Sweet. That's actually really awesome. So these are now the same, right? So this distance is now this value, and test is now equal to the world intersect. Okay. Yeah, so this will give us the correct world position. And this will set it correctly, and then, oh, right, so, no, this is correct. And then closest triangle, so the, so test is 6.2 something, right? So this is not inside the triangles at all. Shit. So is this normalized? I think it would be, but it never hurts to normalize again. No, okay. Right, I think I might have to take a break. Simply because I'm noticing that I'm having massive trouble focusing. And yeah. If I get trouble focusing, I won't actually get anything done. So I think I will just take the I'll stop the stream here, and I want to thank you all for watching, and I'll catch you all next time. See ya.